Since the dawn of humanity, men and women have lifted their eyes to the sky and asked questions that still echo through time. What are those lights? Why do they move, and what lies beyond them? The quest to understand the universe is perhaps the oldest and most profound journey of the human mind. It is a journey of curiosity, of wonder, and of daring imagination. Long before telescopes, satellites, and scientific theories, our ancestors stood under the same sky we see today, and though they lacked the instruments we now possess, they carried the same desire to comprehend the immensity above. This desire is written into the human spirit because to understand the universe is also to understand ourselves. When the first humans looked upward, they saw a dome of stars stretching in every direction, a cosmic theater where the sun rose and set. The moon waxed and waned, and constellations appeared to march across the heavens. With no scientific explanation, they turned to stories. The constellations became gods, heroes, and animals. The heavens became a divine canvas where myths were painted. The Greeks told of Orion, the great hunter whose figure still adorns the night sky. Ancient Egyptians aligned their pyramids with the stars of Orion's belt, believing them to be a celestial guide for souls. In Mesopotamia, the stars were seen as messages from the gods, and priests studied their patterns to predict harvests and political fortunes. The sky was not just a mystery, it was a clock, a calendar, a map, and a sacred text. Humanity's first great achievement was not technology, but interpretation, the attempt to find meaning in the patterns of the universe. As time passed, observation became more disciplined. The Babylonians carefully recorded the positions of the planets, noting their motions with surprising accuracy. The Mayans developed calendars so precise they could predict solar and lunar eclipses centuries in advance. The Chinese recorded comets and supernova, documenting cosmic events that would later confirm modern astrophysical theories. The human quest to understand the universe began as mythology, but it slowly grew into science, carried forward by those who believed that the cosmos followed rules that could be known. One of the great turning points came with the ancient Greeks. Philosophers like Thales, Pythagoras, and later Aristotle and Ptolemy sought natural explanations for celestial phenomena. Thales proposed that the world could be understood not by myth but by reason. Pythagoras imagined that the motions of the heavens followed mathematical harmony, what he called the music of the spheres. Aristotle believed Earth was the center of the universe, a view that dominated thought for nearly 2,000 years. Though his model was wrong, it was revolutionary in its attempt to systematize the cosmos through observation and reason. Human beings had taken a crucial step. The universe was not just to be worshipped or feared, but studied. Centuries later, this quest ignited a revolution during the Renaissance. Copernicus dared to suggest that the sun, not the earth, was at the center of the solar system. His model defied centuries of tradition and religious belief, but it marked a profound leap forward. Galileo, with his telescope, gazed at Jupiter and saw moons orbiting a planet other than Earth. He looked at the surface of the moon and discovered mountains and craters, proving it was not a perfect heavenly sphere, but a world with features like our own. He watched Venus go through phases, confirming that it orbited the sun. With every observation, Galileo cracked the shell of ignorance that surrounded humanity's understanding of the cosmos. The universe was suddenly larger, stranger, and more dynamic than anyone had imagined. Johannes Kepler refined the idea further, discovering that planets move not in perfect circles, but in ellipses, guided by invisible forces. Isaac Newton then revealed the law of universal gravitation, showing that the same force that caused an apple to fall governed the motions of the moon and planets. This was a staggering realization. The heavens and the earth were bound by the same laws. No longer was the cosmos a distant, unknowable realm. It was governed by principles that could be understood, measured, and predicted. For the first time in history, the human mind stretched across the stars, linking them with the earth under our feet. The quest did not end there, it expanded. As telescopes grew more powerful, astronomers discovered new planets, new moons, and deeper regions of space. William Herschel discovered Uranus, the first planet found with a telescope, shattering the notion that our solar system was complete. He also identified countless new stars and even galaxies beyond our own. In the 20th century, Edwin Hubble used the Mount Wilson Observatory to prove that the Milky Way was not the entirety of existence. He showed that other galaxies, like Andromeda, lay far beyond our own, and that the universe itself was expanding. This single discovery transformed our view of everything. We were not the center of the cosmos, nor was our galaxy unique. Instead, we were part of an ever-growing, ever-expanding universe too vast to fully comprehend. And then came perhaps the most profound revelation of all, the Big Bang Theory. Scientists discovered that the universe had a beginning, a moment of creation nearly 14 billion years ago, when all matter, energy, space, and even time itself burst forth from a single point of unimaginable density. The idea was shocking, almost mystical, yet the evidence was undeniable. The cosmic microwave background radiation, the faint afterglow of the Big Bang, still permeates the universe today, a whisper from the dawn of time. For the first time, humanity had not just myths, but a scientific story of creation, a narrative written in light and energy, measurable and observable across the cosmos. But even as science explained more, the universe grew larger in our imagination. The Hubble Space Telescope peered deeper into the sky than any instrument before, capturing light from galaxies billions of light years away. Each image revealed not hundreds, not thousands, but millions of galaxies, each containing billions of stars. The famous Hubble Deep Field showed that even a tiny, seemingly empty patch of sky was overflowing with cosmic wonders. The lesson was humbling. The universe is not only vast, but full, teeming with structures beyond anything we had dared to dream. The quest to understand the universe is not only about measurement and numbers, it is about meaning. When Carl Sagan reminded us that Earth is a pale blue dot, a fragile speck suspended in the immensity of space, he was not diminishing humanity but elevating our responsibility. We are small, but we are capable of wonder. We are tiny, but we are conscious of the infinite. To ask about the size of the universe is not just to ask about distances measured in light years. It is to ask about the scope of human imagination and the hunger for knowledge. This quest is also deeply personal. Every culture has looked to the sky for answers, and every individual has, at some point, stared into the stars and felt a sense of awe. It is a reminder that we are part of something larger, something beyond ourselves. That feeling of smallness is not despairing, it is uplifting. It tells us that our struggles and triumphs, though fleeting on a cosmic scale, are part of a grand story unfolding across billions of years and countless galaxies. Today, our quest continues with technology that extends our senses into realms once thought impossible. Radio telescopes listen to the faint whispers of the cosmos. Space probes travel beyond our solar system, carrying human messages into interstellar space. The James Webb Space Telescope now peers into the earliest moments of creation, studying light that has traveled for over 13 billion years. Scientists map the cosmic web, a vast network of galaxies and dark matter stretching across the universe like a spider's web of unimaginable size. We do not merely observe. We reach, we send machines, we dream of visiting other worlds. And yet, the deeper we go, the more questions arise. What lies beyond the observable universe? Is space infinite, or does it curve back upon itself? Are there other universes, parallel realities beyond our own? What is dark matter, the invisible substance that makes up most of the cosmos, yet cannot be seen? What is dark energy, the mysterious force accelerating the universe's expansion? Each answer we find seems to open 10 more doors. The universe, it seems, is not a puzzle to be completed, but an endless frontier of discovery. But perhaps that is the point. The quest to understand the universe is not about reaching a final answer. It is about the journey itself. It is about the spark of wonder in a child's eyes when they see the stars for the first time. It is about the determination of scientists who spend lifetimes unraveling mysteries that may never be fully solved. It is about humanity's refusal to accept ignorance as permanent, our drive to know, to seek, to imagine. The universe is vast, but so is human curiosity, and it is this pairing, the infinite cosmos and the restless human mind, that creates the poetry of discovery. In truth, when we ask how big is our universe, we are asking more than a question about physics or astronomy. We are asking about the boundaries of knowledge, about the capacity of human beings to grasp what seems ungraspable. The universe is bigger than we can measure, older than we can easily imagine, more complex than we can currently explain, and yet we chase it not because we expect to conquer it, but because the pursuit defines us. To be human is to look up, to wonder, and to seek. So the story of the human quest to understand the universe is not a story of conclusions, but of beginnings. From myths carved into stone, to equations written on chalkboards, to images sent back from telescopes orbiting millions of miles above Earth, the journey continues. Each generation builds on the last, reaching further, asking deeper questions, and daring to dream bigger. And as long as there are stars in the sky, humanity will keep asking, keep searching, and keep imagining. For in the end, the true size of the universe may not be measured in light, years at all, but in the endless capacity of the human spirit to wonder. When we begin to explore the size of the universe, the first step in our journey is to look closer at the place we call home, our solar system. To understand how vast the cosmos is, we must first recognize just how small, yet remarkable, our own neighborhood in space truly is. The solar system is our foundation, our birthplace, and the stage upon which human life has unfolded. By contemplating its structure and scale, we begin to appreciate not only the immensity of the universe beyond, but also the delicate balance that allows life to exist here at all. At the center of our solar system burns the sun, a massive sphere of glowing plasma, holding more than 99% of all the mass within this cosmic neighborhood. It is often described as an ordinary star, a medium-sized yellow dwarf, yet to us it is anything but ordinary. It is the source of light, warmth, and energy that sustains every living creature on Earth. Without it, our planet would be a frozen, lifeless rock drifting in darkness. The sun's gravity anchors the solar system, keeping the planets, moons, comets, and asteroids bound in their eternal dance. At about 1.4 million kilometers in diameter, the sun is large enough to fit more than 1 million Earths inside it, a fact that humbles us when we realize our planet is but a tiny speck in comparison. Orbiting the sun are the 8 recognized planets, each unique, each carrying its own story about the processes that shape the solar system. Closest to the sun is Mercury, a small, rocky world that bakes under scorching heat during the day and freezes in bitter cold at night. With no substantial atmosphere to shield it, Mercury is a raw, silent planet, a survivor from the earliest days of creation. Next comes Venus, often called Earth's twin because of its similar size and composition, but in reality it is a hellish mirror. With temperatures hot enough to melt lead, an atmosphere of carbon dioxide, and clouds of sulfuric acid, Venus is a lesson in what happens when greenhouse gases run wild. Our own Earth, nestled in the 3rd position, sits in a sweet spot, the so-called habitable zone, where conditions allow liquid water to exist and thus life to thrive. Mars follows, smaller than Earth, colder and drier, yet with valleys, mountains, and polar ice caps that speak of a more hospitable past. Scientists dream of sending humans there one day, to stand on the rusty soil and gaze back at the pale blue dot of Earth in the sky. Beyond Mars lies the asteroid belt, a region filled with countless rocky remnants left over from the birth of the solar system. Some of these asteroids may hold clues to the origins of life itself, carrying organic compounds and water frozen for billions of years. Farther out, the gas giants dominate. Jupiter, the largest planet in the solar system, is a colossal world of storms and swirling clouds. Its great red spot, a storm larger than Earth, has raged for centuries. Jupiter's immense gravity acts as a cosmic shield, deflecting or capturing comets and asteroids that might otherwise threaten Earth. Its moons, too, are worlds of wonder. Europa hides a vast ocean beneath its icy crust, where life might possibly exist in darkness. Ganymede, the largest moon in the solar system, is bigger than Mercury itself. Then comes Saturn, adorned with its breathtaking rings made of ice and rock, a jewel of the solar system. Its moon Titan has lakes of liquid methane and ethane, and Enceladus shoots geysers of water vapor into space, hinting at a hidden ocean. The outermost planets, Uranus and Neptune, are ice giants, cold and mysterious, composed largely of water, ammonia, and methane. Uranus rolls on its side as it orbits, perhaps knocked into that tilt by a massive collision long ago. Neptune, with its deep blue hue, hosts the fastest winds in the solar system, racing at supersonic speeds. Beyond Neptune lies the Kuiper Belt, home to dwarf planets like Pluto and countless icy bodies that stretch into the frontier of interstellar space. These distant worlds remind us that our solar system is not simply 8 planets, but a vast collection of celestial objects, all bound by the sun's pull. Even beyond the Kuiper Belt lies the Oort cloud, a hypothetical sphere of icy bodies that may extend nearly halfway to the next star. Though unseen, it is believed to be the source of long-period comets that occasionally streak into the inner solar system, carrying with them ancient material from the earliest days of cosmic history. If the solar system is our home, then the Oort cloud represents its outer fence, marking the boundary where the sun's influence fades into the interstellar medium. Within this grand architecture, Earth occupies a privileged place. We are the only known planet to harbor life, though the possibility exists elsewhere. Our atmosphere, composed of nitrogen, oxygen, and traces of other gases, creates a protective blanket that shields us from harmful radiation and maintains temperatures that allow water to flow freely. The presence of water is crucial, for it is the solvent of life, and our oceans cover more than 70% of Earth's surface. Our magnetic field, generated by the movement of molten iron within our core, acts as a shield against the solar wind, preventing the atmosphere from being stripped away as it has been on Mars. All these factors combine to make Earth a rare oasis in the vast desert of space. But to understand our place in the solar system is also to recognize our fragility. Earth is not immune to cosmic forces. Asteroids and comets have struck in the past, sometimes with devastating consequences. 65 million years ago, such an impact contributed to the extinction of the dinosaurs, reshaping life's trajectory on our planet. Even today, astronomers carefully monitor the skies for near-Earth objects that could pose a threat. Our solar system is a place of beauty and balance, but also of danger and unpredictability. The scale of the solar system itself is difficult to grasp. The Earth orbits the Sun at an average distance of about 150 million kilometers, a distance known as an astronomical unit. Light traveling at 300,000 kilometers per second takes about 8 minutes to travel from the Sun to Earth, but to reach Neptune, the farthest planet, light takes over 4 hours. To imagine the solar system to scale, if the Sun were the size of a basketball, Earth would be a small bead about 26 meters away, and Neptune would be more than 800 meters distant. The solar system is not a cluster of closely packed planets, but a vast expanse where worlds are separated by enormous gulfs of empty space. This immensity challenges our imagination, yet it also provides perspective. When the Voyager spacecrafts, launched in the 1970s, journeyed beyond the outer planets, they sent back images that transformed our view. Voyager 1, before leaving the solar system, turned its camera back toward Earth and captured the famous pale blue dot image. In that tiny speck of light, smaller than a pixel, was everything we have ever known, all human history, all our struggles, triumphs, and dreams. To see Earth from such a distance was to be reminded that while our solar system may be vast, our world is both precious and fragile. Exploration of our solar system continues today, driven by our desire to understand not only where we are but what else is possible. Robotic missions have landed on Mars, rovers have explored its surface, and orbiters have studied its weather and geology. Probes have flown by Jupiter, Saturn, Uranus, and Neptune, capturing images of their moons and rings. The New Horizons mission revealed Pluto in stunning detail, transforming it from a blurry dot into a world of mountains, plains, and frozen landscapes. Each discovery reminds us that our solar system is alive with complexity and surprises. Understanding our place in the solar system also forces us to confront questions of identity. Are we unique, or are we one among many? If life exists on Europa, Titan, or perhaps beneath the surface of Mars, what does that mean for our sense of significance? Our solar system is not just a stage for humanity, but a laboratory of possibility. a reminder that life could emerge under different conditions, in different forms, scattered across the cosmos. At the same time, our solar system is a reminder of connection. Every atom in our bodies was forged in stars that lived and died billions of years ago. The iron in our blood, the calcium in our bones, the oxygen we breathe, all were created in the hearts of ancient stars, scattered by supernova and gathered into the cloud of gas and dust that formed our solar system. To say we belong to the solar system is not merely poetic, it is literal. We are products of its history, children of the stars bound by the gravity of the sun. Yet, as extraordinary as our solar system is, it is but one of billions in the galaxy, each with its own planets, moons, and stories. When we contemplate our place in it, we realize that we are both special and ordinary. Special because Earth is the only known cradle of life, ordinary because the universe likely holds countless other solar systems where similar stories are unfolding. This duality inspires both humility and hope. Humility because we are not the center of all things, hope because perhaps we are not alone. In contemplating our solar system, we are reminded that humanity's journey is only beginning. We have taken our first steps beyond Earth, setting foot on the moon, sending probes to other planets, and dreaming of journeys to Mars. These are not small achievements, they are the continuation of a quest that began when the first humans looked up at the stars and wondered. To know our place in the solar system is to know that we are part of something vast, ancient, and interconnected, a cosmic family bound together by the light of a star, and so when we ask about our place in the solar system, the answer is layered. We are small, orbiting a medium star on a tiny planet in the outer reaches of a spiral arm of the Milky Way, but we are also significant, for we are the solar system's way of knowing itself. The rocks of Mars, the ice of Europa, the storms of Jupiter, all are silent without consciousness. Yet here on Earth, the universe has given rise to beings who can reflect, question, and seek meaning. We are not merely inhabitants of the solar system. We are its storytellers, its explorers, its witnesses. Perhaps that is the most profound realization of all. Our place in the solar system is not just a matter of location, measured in kilometers or astronomical units. It is a matter of perspective, of identity, of purpose. We are travelers on a tiny world, circling a brilliant star within a system of planets, moons, and mysteries. And as we gaze outward into the immensity beyond, we carry with us the knowledge that the story of the universe begins, for each of us, right here, in the solar system we call home. When we move outward from the solar system and begin to consider the galaxy that contains it, our sense of scale deepens to a level that is almost impossible to fully imagine. The Milky Way, the great spiral galaxy we call home, is so vast, so filled with stars, gas, dust, and mysteries, that even the most powerful words struggle to capture its enormity. To understand the size of our universe, we must pause for a moment to contemplate this galaxy, for it is both our immediate cosmic environment and a humbling reminder of just how small even our solar system really is. The Milky Way stretches roughly 100,000 light-years from edge to edge, a disk so wide that a beam of light, moving at the unimaginable speed of 300,000 kilometers per second, would still take 100,000 years to travel across it. That number is easy to say, but difficult to feel. 100,000 years ago, human beings had just begun to walk the earth in the form we know today. Civilizations, cultures, languages, and entire histories could rise and fall in less than a tenth of that time. And yet light, the fastest thing we know, would still be traveling, still crossing the vast expanse of our galaxy. When we look at the Milky Way on a dark, clear night, what we are seeing is not simply a band of stars. We are gazing along the inner arm of this great spiral, peering into a river of light that stretches across eternity. Our sun is only one among an estimated 100 to 400 billion stars that reside in the Milky Way. That range alone gives us pause, for we do not even know exactly how many stars our galaxy contains. It is like standing in the middle of a vast forest and trying to count every tree when the horizon vanishes into haze. Each of these stars is not simply a point of light, but a potential system with planets, moons, and perhaps even life. Recent discoveries of exoplanets, worlds orbiting stars far beyond our own, have shown us that planets are common, perhaps more common than stars themselves. If this is true, then the Milky Way may contain billions of Earth-like planets scattered across its spiral arms waiting to be discovered. The structure of the Milky Way is no less awe-inspiring. It is a barred spiral galaxy, with a central bulge from which arms extend outward in graceful curves. Our solar system lies about 27,000 light-years from the galactic center, positioned within one of the spiral arms known as the Orion Arm. This is not a particularly grand arm, but more like a small spur between the larger Sagittarius and Perseus arms. From this vantage point, we orbit the galactic center at an astonishing speed, about 800,000 kilometers per hour. Yet even at that breakneck pace, it takes our solar system roughly 230 million years to complete a single orbit around the galaxy. In the entire history of Earth, the solar system has completed this orbit fewer than 20 times. The last time we were in our current galactic position, dinosaurs still roamed the Earth, and the continents looked very different. The galaxy's scale is not only spatial but temporal, stretching across billions of years in which stars are born, live, and die. At the heart of the Milky Way lies the galactic center, a region shrouded in dust but glowing with the combined energy of millions of stars. And hidden within that core is one of the most extraordinary objects in the universe, a supermassive black hole known as Sagittarius A*. With a mass equivalent to more than 4 million suns, it is an invisible anchor bending space and time around it. Though black holes consume light and cannot be directly seen, their presence is revealed by the stars that orbit near them at tremendous speeds and by the radiation emitted as matter falls into their grasp. The existence of Sagittarius A* reminds us that even within the beauty of the galaxy, there are mysteries that challenge our understanding of physics itself. The Milky Way is not static. It is a living, evolving system. Stars are continuously being born in regions known as stellar nurseries, vast clouds of gas and dust where gravity pulls material together until nuclear fusion ignites. One of the most famous nurseries is the Orion Nebula, visible even to the naked eye, where new stars are forming right now. Other stars reach the end of their lives in spectacular fashion, exploding as supernova and scattering heavy elements into space. These elements, forged in the cores of stars, are the building blocks of planets, oceans, and even human bodies. In a very real sense, the Milky Way is not just a galaxy of stars. It is a galaxy of stories, of cycles of creation and destruction that ultimately gave rise to us. Beyond the spiral arms and the central bulge lies the galactic halo, a vast, faint sphere surrounding the disk. Here, ancient stars and globular clusters, dense balls of hundreds of thousands of stars, reside. Many of these stars are among the oldest in the galaxy, relics from a time when the Milky Way was young, more than 13 billion years ago. The halo also contains dark matter, the mysterious substance that makes up most of the galaxy's mass but cannot be directly observed. We know it is there because of its gravitational effects, bending the paths of stars and galaxies alike, but its true nature remains one of the greatest mysteries in science. The halo reminds us that even though we can measure and map much of the Milky Way, much remains hidden, waiting to be uncovered. The scale of the Milky Way also reveals itself in the distances between stars. Our nearest stellar neighbor, Proxima Centauri, is more than 4 light-years away. That means the light we see from it tonight left the star over 4 years ago. To put this in perspective, if the Sun were reduced to the size of a marble, Proxima Centauri would be another marble placed hundreds of kilometers away. The stars may appear close together when we look at the night sky, but in reality they are separated by distances so immense that even at the speed of our fastest spacecraft, it would take tens of thousands of years to reach the nearest one. This vast emptiness between stars is part of what makes the galaxy so difficult to comprehend. Yet for all its immensity, the Milky Way is only one galaxy among billions. When we think of its 100 billion stars, we are tempted to believe it must be special. And in one sense, it is special to us because it is our home. But astronomers have observed countless galaxies of similar or even greater size scattered throughout the universe like islands in a cosmic sea. This does not diminish the Milky Way, rather, it connects us to a larger reality, a reminder that our home is both precious and ordinary at once. The human relationship with the Milky Way is also deeply cultural. For millennia, people have gazed at the faint band of light across the night sky and woven stories around it. The Greeks thought it was milk spilled by the goddess Hera, giving the galaxy its name. In other cultures, it was seen as a river of light, a path for souls, or a bridge between worlds. To ancient peoples, the Milky Way was not an abstract collection of stars, but a symbol, a reminder of the connection between Earth and the heavens. Today, though science has replaced myth with measurement, the emotional impact remains. To stand beneath the Milky Way on a clear night, far from city lights, is to feel both humbled and uplifted, caught between insignificance and wonder. The scale of the galaxy also challenges our sense of time. Stars live for millions or billions of years, far longer than the entire span of human history. Civilizations rise and fall in the blink of a cosmic eye. The galaxy itself is more than 13 billion years old, nearly as old as the universe itself. When we think of our own lives, decades in length, they are like sparks in the vast darkness, brief and fleeting, and yet within those brief sparks lies the ability to look outward, to measure, to imagine, and to dream. Perhaps that is what gives human existence its meaning, not its length, but its capacity for wonder. When astronomers map the Milky Way, they use radio telescopes, infrared instruments, and powerful observatories to peer through the dust that obscures much of its light. What emerges is a portrait of breathtaking complexity: spiral arms filled with young, hot stars, star clusters scattered like jewels, nebulae glowing with ionized gas, and the central bulge dense with old, red stars. Each part of the galaxy tells a different chapter of its history, a story written in light and gravity. To study the Milky Way is to study not just one place, but a collection of billions of places, each with its own potential for beauty and discovery. The Milky Way is also not isolated. It belongs to a small group of galaxies known as the Local Group, which includes the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller dwarf galaxies. In about 4 billion years, the Milky Way and Andromeda will collide, merging into a new, larger galaxy. To us, this may sound catastrophic, but on the scale of stars and galaxies, it is a natural process. When the two galaxies merge, most stars will pass by one another without colliding, for the spaces between them are vast, but the shape of both galaxies will change, their spiral arms dissolving into a giant elliptical galaxy. Our solar system will likely survive the encounter, carried into a new position within this merged structure. The thought that our galaxy itself is mortal, destined to transform and change, reminds us that even the largest things we know are impermanent. And yet, through all these scales, stars, arms, clusters, halos, and eventual collisions, one fact stands out: we are part of this galaxy. Our tiny solar system, orbiting an ordinary star, is woven into the fabric of the Milky Way. The atoms in our bodies were forged in stars that once belonged to this galaxy, and the light we see in the night sky is the light of our own cosmic family. When we contemplate the scale of the Milky Way, we are not only humbled by its size, but also connected to it in the most intimate way. It is not simply a galaxy out there, it is home. So when we ask, how big is our universe, we must begin by asking, how big is our galaxy? The answer is staggering: 100,000 light years across, containing hundreds of billions of stars, surrounded by mysteries of dark matter and ancient clusters, alive with the birth and death of suns, and destined to evolve in cosmic dances far beyond human time. To try to hold this scale in the mind is to reach the limits of imagination. And yet, it is within our minds that the galaxy comes alive, for without consciousness, it would simply exist silently, unobserved. With us, it becomes a story, a wonder, a source of meaning. In the end, the Milky Way is both unimaginably vast and profoundly personal. It is the place where our solar system spins, where our sun burns, where our Earth orbits, and where our lives unfold. It dwarfs us, yet it includes us. To know its scale is to be reminded of our smallness, but also of our greatness, for within this immense galaxy, we have found the ability to ask, to measure, and to marvel. The Milky Way is not just a galaxy among billions. To us, it is the galaxy. It is the ground of our cosmic identity, the vast, star-filled sea in which the story of humanity is only one tiny, glittering spark. When we step outside on a clear night and look up at the stars, we often think we are seeing the entire universe stretched above us like a shining dome, but the truth is far more humbling and awe-inspiring. What we see with our eyes is only the tiniest fraction of what actually exists. Our galaxy, the Milky Way, contains hundreds of billions of stars, but it is only one among trillions of galaxies scattered across the universe. To try and understand the enormity of this fact is to attempt to hold infinity in your mind, something we can never completely do, but can only marvel at in fragments of imagination. The leap from thinking about a single galaxy to trillions of galaxies is almost beyond comprehension, yet it is the reality of the cosmos we inhabit. Astronomers once believed that the Milky Way was the entire universe. For centuries, humans thought all the stars in the night sky belonged to our galaxy and that there was nothing beyond it. This belief began to shift in the early 20th century when Edwin Hubble made a discovery that changed our understanding forever. By studying the faint smudges of light in the sky, what were called nebulae at the time, he proved that they were not just gas clouds within our galaxy, but entirely separate galaxies of their own, located unimaginably far away. That revelation shattered the limits of our cosmic perspective. Suddenly, our Milky Way was no longer the whole of existence, but just one island in an endless ocean of galaxies, and what islands they are. Galaxies come in many shapes and sizes: spiral, elliptical, irregular, each holding billions, sometimes trillions of stars. Some galaxies are much larger than ours, like Andromeda, which is on a slow-motion collision course with the Milky Way and will merge with us billions of years from now. Others are tiny dwarf galaxies containing just a few million stars. No matter their size, they are each vast beyond human scale. Imagine a single galaxy with its stars, planets, gas clouds, and black holes spinning through space like a cosmic city. Now multiply that image by trillions, and you begin to glimpse the staggering immensity of the universe. The observable universe, the part we can see with our most powerful telescopes, contains an estimated 2 trillion galaxies. Each galaxy could harbor its own planetary systems, its own cosmic dramas, and perhaps even forms of life we cannot yet imagine. If every galaxy holds hundreds of billions of stars, then the total number of stars in the observable universe rises to a figure so large it feels meaningless: septillions, an almost infinite sea of suns. For every star there may be multiple planets, and for every planet the possibility, however small, of oceans, mountains, skies, and perhaps even beings looking back at their own night sky wondering if they are alone. The space between galaxies is not empty either, though it is unimaginably vast. Galaxies are bound together by gravity into clusters and superclusters, cosmic webs stretching across space like filaments of light. Our own Milky Way belongs to the local group, a small cluster of about 50 galaxies, and that cluster itself is part of the Virgo supercluster, which stretches across 110 million light-years. Beyond even that lies the Laniakea supercluster, a massive network of galaxies more than 500 million light-years across. Each cluster is a shimmering bead on a cosmic web, and the web itself extends outward as far as our telescopes can see. To truly absorb this requires us to change the scale of our imagination. We are used to thinking of distance in miles or kilometers, measurements that make sense in our daily lives. But when we speak of galaxies, we must think in terms of light years. The distance light travels in a year, nearly 6 trillion miles. The Andromeda galaxy, our nearest large neighbor, is 5 million light years away. That means when we look at Andromeda in the night sky, we are seeing it as it was 5 million years ago, long before humans even walked the Earth. Many of the galaxies captured by the Hubble Space Telescope are billions of light years away, showing us light that began its journey when the universe itself was young. To look across galaxies is to look back in time, witnessing the history of the cosmos written in light. Now consider this: if our galaxy were the size of a single grain of sand, the observable universe would be a vast beach stretching miles and miles in every direction, filled with trillions of grains. Each grain would represent a galaxy, and each galaxy would contain billions of stars. Our entire planet, our whole solar system, would be smaller than a speck of dust clinging to that grain of sand. Such a thought makes our human concerns seem both tiny and profound. Tiny, because in the face of such immensity, the things we often worry about are fleeting. Profound, because despite the vastness, we are here, tiny beings on a small world, yet capable of comprehending, at least in part, the grandeur of the universe. The discovery of trillions of galaxies has raised profound questions. If the universe is so large, are we truly alone? Statistically, it seems unlikely. With so many stars and so many planets, the probability that life has arisen elsewhere seems almost certain. Yet the distances between galaxies are so immense that even if other civilizations exist, we may never reach or communicate with them. This paradox, the overwhelming likelihood of life elsewhere and the silence of the cosmos, is one of the greatest mysteries of science. It humbles us and reminds us how fragile and unique our place is in the universe. Beyond the observable universe lies an even deeper mystery. The universe we can see is limited by the speed of light and the age of the cosmos. Light has only had about 13.8 billion years to travel, so we cannot see farther than that horizon, but most cosmologists believe the universe extends far beyond what we can observe, possibly infinitely. The trillions of galaxies we know of may be only a small fraction of what truly exists, and if the universe is infinite, then the scale of galaxies stretches on forever, with no end, no boundary, no edge. And within these galaxies are countless cosmic wonders. There are stars so massive they burn millions of times brighter than our sun, and black holes so dense that not even light can escape them. There are nebulae, vast clouds of gas and dust, where new stars are born like cosmic nurseries. There are galaxies colliding and merging in slow dances that last billions of years. There are quasars, galaxies with supermassive black holes at their centers, shining so brightly they outshine entire galaxies. Each galaxy is not just a collection of stars, but a stage for the grand theater of cosmic evolution. The sheer abundance of galaxies also forces us to confront the limits of human knowledge. No matter how advanced our telescopes become, we will never map all the galaxies, never know every star, never touch every planet. The universe is too vast, too expansive, too infinite. And yet, the fact that we can see as much as we do is a miracle of science. The images captured by the Hubble and James Webb Space Telescopes are not just pictures, they are windows into the distant past, glimpses of galaxies billions of light years away. They remind us that while we may never grasp it all, we can still marvel at the fragments we are privileged to witness. To think about trillions of galaxies is to confront both our insignificance and our significance. On the one hand, we are small, a single species on a tiny planet orbiting a single star among trillions. On the other hand, we are beings who can look at the stars and ask questions, beings who can measure distances and imagine infinities, beings who can create meaning in the face of immensity. The galaxies do not know they exist, the stars do not ponder their own light, but we do. We carry within us the ability to marvel, to be humbled, to dream. In the end, perhaps the greatest gift of realizing there are trillions of galaxies is not just the awe it inspires, but the perspective it gives. It teaches us that our quarrels, our divisions, our worries are small against the backdrop of eternity. It challenges us to rise above pettiness and see ourselves as part of something greater. It reminds us that while we may be small, we are not insignificant, for we are the universe made conscious. The galaxies come alive in thought and wonder. So when we ask how many galaxies are out there, the answer is almost beyond imagination. There are trillions upon trillions, each a vast world of stars and mysteries, and beyond them, perhaps infinitely more. We are floating in a universe without edge, surrounded by a sea of galaxies that stretches farther than light itself can travel. To think of this is to feel humbled, awed, and inspired all at once. And perhaps that is the truest measure of the universe, not just in its size or its numbers, but in the wonder it awakens in the human heart. When we begin to speak of the observable universe and the way light travels across it, we step into a realm where numbers, distances, and timescales become so immense that human language struggles to hold them. The observable universe refers to the portion of the cosmos we can see, limited not by the size of the universe itself, but by the speed of light and the age of everything around us. To understand this, we must remember that light, while the fastest thing we know, does not move instantaneously. It travels at 300,000 kilometers per second, which is almost unimaginably fast compared to anything on Earth, yet in the cosmic scale it is still finite. This means that when we look at the universe, we are not seeing it as it is now, but as it was in the past, depending on how long it took light to reach us. The distance light covers in 1 year is called a light year, about 6 trillion miles. For comparison, it takes light just a little over 1 second to travel from the moon to Earth. It takes 8 minutes to travel from the sun to Earth. Already, this shows us how vast space is. The sun feels close, and yet its light is already minutes old when it touches our eyes. When we look at the nearest star system, Alpha Centauri, the light we see has traveled more than 4 years. By the time it reaches us, those photons have been racing across the void since, before most of our recent memories were even formed. If the star had disappeared yesterday, we would not know until more than 4 years from now. When we expand this perspective, things grow staggering. The light we see from the Andromeda Galaxy began its journey too, 5 million years ago, before humans even existed as a species. When that light first left Andromeda, early human ancestors were walking upright for the first time in Africa. Those ancestors never knew that one day their descendants would gaze into the sky and witness that faint blur, unaware they were seeing a galaxy of 1 trillion stars as it was millions of years ago. This is the meaning of the observable universe. Everything we see is already history. Every star, every galaxy, every glowing object in the night sky is a message from the past, and the farther away we look, the deeper into time we are peering. Scientists estimate that the observable universe stretches about 93 billion light years across. At first glance, this seems confusing. How can the universe be only 8 billion years old and yet be 93 billion light years wide? The answer lies in the expansion of space itself. As the universe expands, the galaxies within it move farther apart, and the light traveling toward us stretches as well. So the galaxies we observe are not only far away, but also moving, carried by the growth of the universe like boats drifting apart on an inflating ocean. This expansion means that some of the light we see began its journey billions of years ago, when those galaxies were much closer, but as the light traveled, the space between us and them stretched, making the present distance far greater than the time it took for light to travel. The cosmic horizon defines the limit of what we can observe. Beyond this horizon lies the unobservable universe, parts of the cosmos too far away for their light to have reached us yet. The horizon is like the edge of a bubble around Earth. Inside, we can see; outside, we cannot, though it may still exist. This is not the edge of the universe itself, only the edge of visibility. It is like standing in a foggy valley. You can only see so far, even though you know the landscape continues beyond what your eyes allow. Similarly, astronomers believe the universe extends far beyond what we can detect, perhaps infinitely, but our observable universe is bound by the speed of light and the time since the Big Bang. The observable universe, then, is not just a map of space, it is a map of time. When we look deep into space, we look back into history. This is why telescopes are not just instruments of sight, but of time travel. When the Hubble Space Telescope focused on a seemingly empty patch of sky for days and revealed thousands of faint, ancient galaxies, what we were seeing was the universe as it existed billions of years ago, when those galaxies were young. With the James Webb Space Telescope, we now peer even deeper, closer to the birth of the first stars, when the cosmos was still shrouded in darkness. These images are not snapshots of the present, but windows into epochs long gone. The universe we see is a kind of time machine, showing us layer upon layer of cosmic history as light delivers its ancient messages. Every second, light from distant stars and galaxies streams into Earth's atmosphere. Some of it has traveled millions or billions of years to reach us. Each photon carries with it a story, a record of where it came from and when it began its journey. To catch that light in a telescope is to catch whispers from the dawn of time. And what is perhaps most mind-bending bending is that much of the universe we see no longer exists in the form we observe it. Galaxies have merged, stars have died, new stars have formed, but we see them frozen in the state they were when their light set out. The night sky, then, is not just a picture of what is, it is a mosaic of what once was. The concept of light travel also reshapes how we think about our place in the cosmos. Our lives are measured in decades, maybe a century if we are fortunate. But the light crossing the universe measures time in billions of years. For us, 1 year is long. For light, it is nothing more than a step. The contrast between our scale of time and the universe's scale is dizzying. Our entire recorded history, civilizations, empires, religions, inventions, is a blink compared to the age of the light reaching us from distant galaxies. Some of that light began its journey when Earth was young, long before plants or animals existed. To look at the universe is to realize that we are a momentary flicker within a grand and ancient story. Another fascinating aspect is how light itself stretches as the universe expands. This is known as redshift. The farther a galaxy is, the more its light shifts toward the red end of the spectrum as space expands during its journey. By studying this redshift, astronomers can measure not just distance, but also how fast galaxies are moving away from us. This discovery, also made by Edwin Hubble, gave us the clearest evidence that the universe is expanding. It also means the observable universe is not static but dynamic, a shifting and growing canvas of light. But what lies beyond the observable universe? This question has puzzled cosmologists for decades. If the universe is truly infinite, then there may be regions so distant their light will never reach us, no matter how long we wait. These regions are cut off from us forever, unreachable and unknowable. Even within the observable universe, there are galaxies so far away that their light is just barely reaching us now, and because of cosmic expansion, the space between us is widening so fast that their future light will never arrive. They are receding faster than light can bridge the gap, not because they are moving through space faster than light, but because space itself is stretching faster than light can cover. These galaxies are effectively lost to us, visible only as ghosts from the past. To think of this is both humbling and haunting. It means that even as we build more powerful telescopes, there will always be a horizon beyond which we cannot see. The universe keeps secrets we will never uncover, not because of our lack of technology, but because of the laws of nature itself. The observable universe is like a theater in which we watch the performance of light, but beyond the curtain lies a stage too vast for us to glimpse, and yet what we can observe is extraordinary. To know that the observable universe is 93 billion light years across is to recognize the sheer magnitude of the cosmos. Imagine crossing one light year, it would take 6 trillion miles of travel. Now multiply that by 93 billion. The scale overwhelms our imagination, and within that space lie billions of galaxies, each with billions of stars, each with the possibility of planets. The observable universe is not empty, it is overflowing with structure, complexity, and beauty. Light travel also offers a philosophical lesson. It reminds us that the present we live in is always interconnected with the past. The starlight that shines down on us tonight began long before we were born. Some of it left its star before our species even existed. We live in a universe that constantly delivers the past into our present. This gives us a sense of continuity, a reminder that we are part of a cosmic story stretching back billions of years and continuing long after we are gone. Perhaps the most awe-inspiring thought is that we ourselves are woven into this story. The atoms that make up our bodies were forged in the hearts of stars billions of years ago. The light we see from the distant universe carries the history of those same processes on a cosmic scale. When we gaze at the night sky, we are not just spectators but participants, connected to the very light that shaped us. The observable universe is not separate from us. We are a tiny piece of it, able to look back upon itself with wonder. So when we ask about the observable universe and the travel of light across its vastness, we are really asking about the limits of human understanding, the boundary between what can be known and what lies forever beyond reach. The universe may be infinite, but our window into it is finite, framed by light and time, and yet, within that window is enough to fill us with wonder for 1,000 lifetimes. Every star, every galaxy, every photon of light is a reminder that we live in a universe vast beyond imagination, ancient beyond measure, and beautiful beyond words. The observable universe is not merely big, it is a reflection of the most profound truth we know, that we are part of something larger than ourselves, something that stretches across billions of years and billions of light years. To grasp this, even imperfectly, is to awaken to a sense of awe that shapes how we see ourselves and our world. And though we may never see beyond the horizon, what we can see is enough to remind us that we are part of a cosmos so magnificent that our words will always fall short, but our wonder will never end. When we ask how big the universe is, we often look for numbers, measurements, and distances, but the true weight of the answer is not only scientific, it is deeply philosophical. The sheer vastness of the cosmos does something to the human spirit. It humbles us, challenges us, and forces us to reflect on what it means to exist in such a boundless reality. To contemplate the universe is to contemplate ourselves, our fragility, our significance, and our longing for meaning in a world so unimaginably immense. Numbers alone cannot capture this. The immensity of the universe is not just about size, but about perspective, and that perspective has the power to change how we live, how we love, and how we see our place in everything. Standing under the night sky, you cannot help but feel small. The stars glitter like tiny lights, yet each one is massive beyond imagination, many larger than our own sun, many with planets orbiting them, each system its own miniature universe. Then you realize that the stars you see are only a fraction of the stars in our own galaxy, and our galaxy itself is only one among trillions. The immensity stretches outward in all directions, and suddenly the worries of daily life seem so trivial. The argument you had earlier, the stress of tomorrow's responsibilities, the fleeting concerns of pride or insecurity, all of it shrinks in the face of the cosmos. This is one of the first philosophical gifts of the universe's vastness. It puts our problems into perspective. It reminds us that life is short, precious, and fleeting, and that our energy is better spent on love, kindness, and wonder than on bitterness or fear. But the universe's enormity does more than humble us. It inspires us. When we realize that we are made of stardust, that the very atoms in our bodies were forged in the hearts of ancient stars, we begin to feel a deep connection to the cosmos. We are not separate from it. We are not outsiders gazing at it from a distance. We are participants born of the same forces that created galaxies and nebulae. To know this is to feel awe at the fact that the universe has become conscious of itself through us. In our thoughts, our curiosity, our questions, the cosmos is reflecting on its own existence. That is perhaps the most profound meaning hidden in the immensity. Though we may be small, we are also extraordinary, for we can contemplate what surrounds us. The size of the universe also challenges us to think about the limits of human knowledge. No matter how advanced our technology becomes, there will always be parts of the universe beyond our reach. The observable universe stretches 93 billion light years, but beyond that horizon lies an endless mystery. We will never see it, never measure it, never explore it. This humbles our arrogance as a species. We pride ourselves on our discoveries and our mastery of science, yet the truth is that we will never know it all. The universe is too vast, too infinite, too mysterious, and maybe that is a good thing. Mystery gives life depth. It keeps us searching, questioning, and yearning. It keeps alive the flame of wonder that drives science, art, and philosophy alike. There is also a sobering aspect to the universe's size. When we consider how vast it is, we cannot avoid the question of loneliness. Are we truly alone in all this immensity? Statistically, it seems improbable. With trillions of galaxies, each with billions of stars and countless planets, it seems almost certain that life must exist elsewhere. And yet, the silence of the cosmos weighs heavily on us. Despite our listening, our searching, and our hopes, no clear voice has answered this paradox. The universe so vast it should teem with life, yet so silent we feel alone, forces us to confront our place in existence. Perhaps life is rare, Perhaps civilizations rise and fall before they can reach one another, or perhaps the distances are simply too great to ever be crossed. Whatever the truth, the universe reminds us that life on Earth is precious and fragile, worth protecting and cherishing, for it may be rarer than we imagine. The immensity also raises questions of meaning. If we are so small in such a vast cosmos, do we matter? Do our actions, our dreams, our lives mean anything in the face of galaxies colliding and stars being born and dying across billions of years? It would be easy to think we are insignificant, a flicker of dust in an endless void. Yet perhaps it is the opposite. The very fact that we can love, hope, and dream in such an immense and indifferent universe gives our lives meaning. The universe does not assign us purpose, but we can create it. We can find beauty in fleeting moments, joy in relationships, and courage in struggle. Against the backdrop of infinite space, our smallness gives intensity to our existence. If everything were permanent and infinite, nothing would matter. It is precisely because we are fragile, finite, and fleeting that life matters so deeply. Think of this. The light of distant stars takes millions of years to reach us, yet here we are to see it. The universe has stretched across time and space to give us this moment. We may be small, but we are not irrelevant. We are the observers, the storytellers, the dreamers. Without us, the universe would go on existing, but without reflection, without meaning, without consciousness. In this sense, our lives, however brief, bring something vital to the cosmos, awareness. That is why many philosophers and scientists say we are the universe becoming aware of itself. Our very thoughts, our awe, our wonder are not trivial. They are the highest expression of the universe's vast potential. The vastness also teaches us humility. For much of history, humans believed the Earth was the center of the universe and everything revolved around us. That illusion gave us a sense of importance, but it was fragile and false. Science revealed a different truth. We are not at the center. We orbit an average star on the edge of a galaxy that is one among trillions. This could be crushing, but it can also be liberating. No longer must we believe that the universe exists solely for us. We can instead marvel at its beauty, free of the burden of thinking we are the central characters in its story. We are part of something much larger, and that realization invites humility, gratitude, and reverence. Yet the philosophical meaning of vastness is not only about humility, it is also about courage. To look at the cosmos and know how small we are can be frightening. It can make us feel like nothing matters, but courage means staring into that immensity and still choosing to live fully, to create meaning, to love passionately, to explore boldly. The universe may not give us purpose, but it gives us the canvas on which to paint one. Vastness is not meant to crush us, but to remind us of our freedom. We can make our brief lives as luminous as the stars we admire. The vastness of the universe also calls us to unity. When you realize that our planet is a pale blue dot floating in the darkness, all divisions of race, religion, and nationality seem absurd. Borders are invisible from space. Our conflicts, our pride, our wars are nothing compared to the scale of the cosmos. We are one species sharing one fragile home, traveling together through an infinite universe. This realization, so beautifully expressed by astronomer Carl Sagan, is one of the greatest gifts of cosmic perspective. If more people truly felt the weight of that truth, perhaps we would live with more compassion, more wisdom, and more responsibility toward each other and our world. The immensity also stirs in us a longing for exploration. To look at the stars and know there are countless worlds beyond them awakens a desire to see, to travel, to discover. We may never cross to other galaxies, but the human spirit longs to reach farther, to step beyond Earth, to explore other planets, to stretch the boundaries of our horizon. The universe's vastness is not only a challenge but an invitation to expand our minds, our technology, and our imagination. Exploration is not just about survival, it is about answering the deepest call within us, to seek meaning by going farther than we ever have. At the same time, the immensity reminds us to value the present. Because the universe is so vast, so eternal, our short lives become even more precious. The laughter of a friend, the beauty of a sunset, the quiet of a starry night. These moments are brief but meaningful. They are our treasures in the face of eternity. The vastness of the cosmos teaches us not to waste them, not to let life slip by unnoticed. It whispers to us that while we may not live forever, We can fill our days with love, creativity, and wonder, and that is enough. Ultimately, the philosophical meaning of the universe's vastness lies in balance. We are humbled by our smallness, yet uplifted by our awareness. We are reminded of our limits, yet inspired to explore. We are shown the silence of the cosmos, yet moved to fill it with our voices, our stories, our dreams. The universe does not answer our questions, but it gives us the stage on which to ask them, and in the act of asking, we find ourselves. So when we look into the night sky and ask how big the universe is, the answer cannot be given only in numbers and distances. The true answer is written in how the immensity changes us. It teaches us humility, courage, unity, wonder, and gratitude. It reminds us that life is short but beautiful, fragile but meaningful. It challenges us to rise above pettiness, to live with love, and to dream with boldness. The universe may be infinite, but so too is the capacity of the human spirit to wonder. And in that wonder, we find not only the meaning of the cosmos, but also the meaning of ourselves.